Hello, today I'm going to talk to you about lesson 6-1. This is called the Amazing Amanda activity, and in this lesson they talk about this student Amanda who claims to have an amazing talent. She says, tell me the number of sides in a polygon, and I can tell you two things, not only the sum of all of its interior angles, but also the sum of its exterior angles, just by you telling me how many sides it has. So is this possible, or does she have a special gift, or is this magic, or how does this work? So what you're going to want to do is, for each of these shapes down below, you're going to want to figure out how many sides are in each one, first of all, and how many triangles can come from that, how many non-overlapping triangles can you draw within it, and then let's extend a side of each regular polygon to create an exterior angle. So in these, it's talking about these being regular polygons. A regular polygon means all sides are congruent and all angles are congruent. So that's talking about not only the interior angles are congruent, but the exterior angles as well. So let's take this first one. This is a triangle, so the number of sides is equal to 3. Can I divide it into more interior triangles, non-overlapping triangles? No, I cannot. So how many triangles are there? There's just one. And I'm going to extend one side to create an exterior angle. As we'll see later on, this interior angle is 60 degrees. We actually know that because it's equilateral, right? If that's 60 degrees, what is the exterior angle? This is a linear pair, so it's just going to be 120 degrees. 180 minus 60 is 120. Well, let's do the same thing for this. This is a square, so n is equal to 4. How many interior triangles can I draw? I can draw only 2. And what is one of the exterior angles? I'll extend a side. We already know it's a square, so this is a 90-degree angle and another 90-degree angle, because again, they're linear pairs. This is a pentagon, so n is equal to 5. How many interior triangles are there? Well, let's count. 1, 2, 3. And let's draw an exterior angle. You can do this from any of the sides, but I'm going to extend this side. And you can see that's an example of an interior angle. Interior and exterior, should I say. So this is a hexagon. N is equal to, n is equal to 6 for a hexagon. How many interior triangles are there? 1, 2, 3, 4. And we'll extend a side. We'll just say this one. This is an octagon. N is equal to 8. How many interior triangles are there? Turns out there's 1, 2, 3, 4, 5, 6. 6 interior triangles can be drawn inside an octagon. Okay, so we have this table we're going to fill out. By doing so, you'll see the pattern better of how Amanda is doing this trick. The number of sides in a triangle, 3 sides. How many non-overlapping triangles? Just 1. The sum of the interior angles. So it turns out, however many triangles, the reason why we were counting triangles is however many triangles there are, for each triangle, there's 180 degrees. We already know that, right? All 3 angles add up to 180. How many triangles were there in a triangle? Just 1. So the sum of the interior angles, we already knew that adds up to 180. The measure of each interior angle for a regular triangle, for an equilateral triangle in this case, it would be the sum of the interior angles divided by however many interior angles there are. So each one is 60 degrees. The measure of each exterior angle, you could say 180 minus 60 is equal to 120, or this is another way you can do it. 360 degrees divided by however many exterior angles there are also gives you 120 degrees for the exterior angle. The sum of the exterior is going to be just 360. Quadrilateral. A regular quadrilateral is called a square, and it has 4 sides. However, how many non-overlapping triangles are there? We counted 2. What's the sum of the interior angles? 180 times that 2 is equal to 360. The measure of each interior is the sum of all the interior divided by however many interior angles there are, which gives you 90 degrees for each interior angle for a square. The measure of each exterior angle, the easiest way to calculate it is just 360 divided by however many angles there are. In this case, it's again 90. For a square, it just happens to be the same as we saw up here. What's the sum of all the exterior? Simply 360. What do we call a 5-sided figure? We call that a pentagon. How many non-overlapping triangles are there? We counted 3. So the sum of the interior is 180 times 3, 540. What's the measure of each interior, should I say? 540 divided by 5, which is 108. And each exterior is 360 divided by however many there are. In this case, you get 120. No, that's not right. 72, sorry. Looking at the wrong line. So yeah, 108 and 72 should be supplementary. They're a linear pair, and this is correct. Okay, what do you get for a hexagon? Hexagon is a 6-sided shape. So the name of it is a hexagon. How many non-overlapping triangles are there? There's exactly 4. The sum of the interior is 180 times that 4, which gives you 720 for the sum of the interior. Each interior is 720 divided by however many angles there are. So it's 720 over 6, which is 120. Each exterior is 360 over 6, which is 60 degrees. Again, these are a linear pair. The sum of the exterior is 360 degrees. Heptagon, we don't use this one as much, but heptagon means 7 sides. How many non-overlapping triangles are there? Well, you can see, we don't have this one drawn up here at the top, but you can figure it out from the pattern. However many sides there are, it's always going to be 2 less than that. So 7 minus 2, there's 5 non-overlapping triangles, which means the sum of the interior angles is 180 times 5, which is 900. Let me draw that 9 a little better. Each interior is 900 divided by 7, and this one we're going to have to round, so I'm going to draw this dot above to show that it's rounded. It's approximately equal to 128.6. 128.6. And then what is each exterior? So that would be 360 over 7. And again, this is approximate. That'd be about 51.4 degrees. But this last one is not approximate. It always adds up to exactly 360 degrees for an exterior, for the sum of the exterior angles. What is an 8-sided figure called? It's called octagon. How many interior triangles? 6. Sum of the interior, 180 times 6, which is 1080. Each interior is 1080 divided by 8, which gives you 135. Each exterior is 360 over 8, which gives you 45. Again, linear pair. And the sum of the exterior, as always, 360. Nonagon, 9-sided. How many triangles? 7. Sum of the interior, 180 times 7. And that comes out to 1260. Each interior, 1260 over 9. And that comes out to being 140 degrees. 360 over 9 gives you exactly 40 degrees for each exterior. And all the exterior adds up to 360. What is a 10-sided figure called? It's called a decagon. You probably know that prefix dec means 10. How many triangles would there be in a decagon? 8. 180 times 8 is the sum of the interior. That gives you 1440. Each interior is 1440 over 10, which is 144. And each exterior is 360 over 10, which gives you 36. So as you can see, the interior angles, the measure of each interior gets more and more obtuse. It gets bigger and bigger as you go down. The exterior angles, on the other hand, get smaller and smaller as the number of sides increases. Let's do 2 more rows and then we'll be done with this table. What do you call a 12-sided figure? It's not a decagon, but it's called a dodecagon. So it has do in front of the decagon. How many triangles would there be? 12 minus 2 is 10. 180 times 10 is 1800. Each interior would be 1800 over 12, which gives you 150 degrees. 360 over 12 is 30 for each exterior. And the sum of the exterior is always 360. Okay, in general, we could go on and on and on, but wouldn't it be nice to just summarize it in one line? If you had n number of sides in a polygon, what's the general name? We're just going to call that a real easy name, an n-gon. N-gon has how many triangles? Well, it's always n minus 2. What's the sum of the interior angles? It's always 180 times however many triangles there are. So in this case, it's just 180 times n minus 2. What is the measure of each interior? Well, it's the sum of the interior divided by how many interior angles there are. So 180 times n minus 2 over n. What is the measure of each exterior? It's always 360 divided by n. What is the sum of the exterior? Always 360. So this last one is really the most important one, and you're going to want to know this one well. Okay, moving on to page 2. What is the sum of the interior? We just wrote that down. And that would just be 180 times n minus 2. Each interior, the same number, 180 times n minus 2, but we have to divide that into how many different angles. There's n different interior angles. And this is only true for regular polygons because that's the only way you would know that each interior angle is the same. If they're all different, then this formula doesn't work. The sum of the exterior angles is always going to be 360. And each exterior angle is always going to be 360 over n. And this is, again, only true for regular polygons. So as I said on the other page, the sum of the interior and exterior angle pairs is always going to be equal to 180 because they're supplementary. They form a linear pair, and a linear pair is supplementary. Okay, so let's go through a couple more examples where you have figures provided. How many triangles are in these polygons? Well, first of all, what's the number of sides? N is equal to 6, right? Let's see. We would expect it to be n minus 2 or 4. Do we get 4? So the number of triangles is equal to n minus 2, which in this case is 6 minus 2. Sum of the interior, well, remember, sum of the interior angles is however many triangles there are, but each triangle has 180 degrees worth of angles in it. So 180 degrees times 4 is equal to 720 degrees. Sum of the exterior angles is always going to be 360. For this one, and there was 4 sides, so there's only 2 triangles. Sum of the interior, 180 times 2 equals 360. And it just so happens that the sum of the exterior is exactly the same whenever you have a quadrilateral. So we can say number of triangles, n minus 2 is equal to 4 minus 2 is equal to 2. Dodecagon, well, that means n is equal to 12. Number of triangles, n minus 2, which is 12 minus 2. So there's only 10 of them. Sum of the interior angles is 180 degrees per triangle times 10 triangles, 1800 degrees total. Sum of the exterior, as always, is 360. Okay, calculate each interior angle and each exterior angle for the following regular polygons. Well, first of all, what kind of polygon? It's a pentagon, so n equals 5. What is the sum of the interior? This is always a good one to know. It's going to be 180 times n minus 2, and in this case, it's 5. So that's 180 times 3. So the sum of the interior is 540. Each interior is 540 over 5, which gives you 108 degrees. Each exterior, on the other hand, is always 360 over however many exterior angles there are, which is going to be 72 degrees. So that's going to be the way you're going to do this for all of them, whenever you're asked these kinds of questions. First, determine how many sides there are. In this case, this is a 10-sided figure, or a decagon. The sum of the interior is equal to 180 times n minus 2. 180 times 8 is equal to 1440. Each interior, sorry, let me get on the screen. Each interior then is going to be 1440 over 10, which is 144 degrees. Each exterior is 360 over n, or in this case 360 over 10, which is 36 degrees. And let's see what we got. Now we have some algebra problems. The last ones on this page are all algebra. Use what you know to determine the value of each variable. Well, I know we have some interior angles, and I know there's 4 of them. All of them are going to give me, if you add up all of them, you get the sum of the interior. But I also know the sum of the interior of a quadrilateral n is equal to 4, right? When n is equal to 4, then I get 4 minus 2 times 180. So that's 2 times 180 is equal to 360. I also know that the sum of the interior angles is just x plus 2x plus 3x plus 4x. So all of them added up equals that, but it's also equal to 360. So I can set those equal to each other. If you add the left side, you get 10x equals 360. So this is not too hard. X is just equal to 360 divided by 10, or 36. This next one does not deal with interior angles, but rather 4 different exterior angles. The good thing is the sum of the exterior angles always is equal to 360, no matter how many of them there are. And what else do I know? I know the sum of the interior the sum of the exterior is just all four of these added up. So x minus 1 plus 78, oops, plus 79, sorry, I wrote that wrong. 79 plus x plus 10 plus 2x equals 360. Let's add up our, combine our like terms. So we get x, x, and 2x, that's 4x. Negative 1 plus 79, 78, plus another 10 is 88. And that's equal to 360. Subtract 88 from both sides. 4x is going to be equal to 272. Divide both sides by 4. X is equal to, 4 goes into that 6 times, 68. So x is equal to 68. Okay, so that one you had to know to add up all your interior and set it equal to the sum of the interior. Add up all your exterior, set it equal to the sum of the exterior, which happens to always be 360 every time. These last two are a little bit different. It's giving you the measure of an interior angle of a regular polygon. It has to be regular, otherwise this doesn't work. But we also know the measure of an interior angle of a regular polygon is given by this formula, 180 times the number of sides minus 2. That's the sum of the interior, but the measure of each interior is that divided by n. And I know this is equal to the number they told me. So what I'm going to do is multiply both sides by n. I get 180 times n minus 2 is equal to 144n. Distribute this. 180n minus 360 is equal to 144n. I'm going to move my 144n over. I get 36n minus 360 is equal to 0. Move my 360 over. 36n is equal to 360. Divide both sides by 36. I get n is equal to 10. So this, if this is the measure of your interior angle, you must have a decagon, or n equals 10. Let's try that for another one. If each interior angle is 108, use the same formula. The measure of an interior angle is given by this formula. Set it equal to 108. Again, multiply both sides by n. I'm going to distribute. Move my 108n over. I get 72n minus 360 is equal to 0. 72n equals 360. And if you divide both sides by 72, you get n is equal to 5. So this is a pentagon.